Now we have to see what is adiabatic process and work done in adiabatic process, right? So adiabatic process. Adiabatic process. It is a process. It is a process in which no exchange of heat takes place from system to surroundings and vice versa, right? So what is adiabatic process? It is a process in which no exchange of heat takes place from system to surroundings and vice versa. So that means what happened in the system, in this process. See there, if you take one example, let us take a system which contains 1 gram mole gas, right? Let us take a system. Here I am taking a system. System means cylinder with the piston, right? In this cylinder there exists 1 gram mole gas. Okay, 1 gram mole gas. Here I am taking 1 gram mole gas, right? So when it is compressed fastly, see that when it is compressed fastly, then what happened? Immediately heat is generated in the gas, right? That means the heat of the gas is generated. That means what happened? As a result, it raises its temperature. As a result, temperature is raised. When we compress it fastly, heat developed in the system. As a result, its temperature is raised. So that is so happen in case of compression fastly. Right? Now, when it is expanded fastly, what happened? Immediately, its system lost its heat. As a result, what happened? Its temperature decreased. When the gas is expanded, so this gas which is present within the system, its heat is lost. Therefore, what happened here? Its temperature also reduced. So that means where the gas become cool. Right? So this is so happen in adiabatic process. Right? So there is no exchange of heat from surroundings to system and system to surrounding, just like isothermal process. In isothermal process, what happened when we compress it slowly? So developed heat is shared to the surroundings to make the temperature constant. When it is expanded slowly, so when the heat lost by the system is balanced by heat received from the surroundings to make the temperature constant. That is what happens in isothermal process. But in case of adiabatic process, there is no exchange of heat from system to surroundings and surrounding to the system. Now our aim is, we are going to find out work done in adiabatic process. Just like work done in isothermal process, now I am going to derive the equation work done in adiabatic process. So in this adiabatic process, where we can use one formula, PV power gamma equal to constant. PV power gamma equal to constant. This may be written as PV power gamma equal to constant, K equal to RT. Okay. So where we can use this formula to find out work done. Okay. So let us see what is work done in adiabatic process. Work done in adiabatic process. Work done in adiabatic process, right? So here, let us take a system which contains 1 gram mole gas. Here what I am taking? I am taking a system which contains 1 gram mole gas. 1 gram mole gas. System contains 1 gram mole gas. Understand? Here also we can use PV diagram. Okay, PV diagram. So here I am going to use this curve. So on the x-axis I am going to take volume, on the y-axis let us take pressure. Okay, now, so initially, before going to expand, initially its volume of the gas, volume of the system can be VF, VI, initial volume. The pressure of this gas can be taken as PI. Okay. Now, the final, after expansion, final volume can be considered as VF, and we know that as the volume increased, its pressure decreased according to Boyle's law. Right? Here you have to take PF. Okay, PI, PF, VI, VF. Just like in isothermal process. Now we have to find out work done during the expansion. When it is expanded, when the gas of the cylinder is expanded. So how much work is done by the gas, right? When it is expanded, the work done by the gas, by the system against the surroundings. Okay, right. So how much work is done, we have to find out. Initially, let us find out small work done for small expansion of the gas, right? Here I am using small work, here I am considering small area. Here I am using CD, C dash, D dash. So at this point, change in volume can be taken as dV. At this point, change in volume can be taken as dV. Right? Now the work done at this point, can be taken as, yesterday I told you how can we get the work in terms of pressure and volume. Right? Small amount of work done during the change in volume at constant pressure. At this point I am assuming pressure is constant, right? Due to the small change. Then the work done can be taken as dW equal to PdV. dW equal to PdV, small value where the pressure is constant, right? Now integrating on both sides. If you want to get total work done, let us integrate on both sides. Now take integration. Integral d omega equal integral PdV. Right? Integral d omega equal integral PdV. Okay. Now, so integral d omega dw can become w equal to work equal to. Here limits goes to Vi to Vf, where volume varied between the limits Vi to Vf and PdV. So just now I have seen one formula, PV power gamma equal to constant. Okay, from this one, P equal to, so what we get there, K by V to the power of gamma. So assume this is equation number 1, this is 2, and substitute 2 in 1. Substitute 2 in 1. Okay, so what we get if we substitute 2 in 1, see there we get W equal to, so integral Vi Vf, and here you have to substitute P value K by V to the power of gamma into dV. Where K is constant, let us write outside. Then finally what we get there, W equal to K into integral Vi to Vf, okay, Vi to Vf, and 1 by V to the power of gamma into dV. Right? So let us send the denominator into the upwards direction. So W equal to, what we get there finally, K into integral Vi to Vf. So it will become V to the power of minus gamma into dV. Right? So integration of this term will become like this. See there? K into integral of this value become, right? V to the power of minus gamma plus 1 by minus gamma plus 1. Right? Into dV. Right? So let us write the denominator outside and we'll get there K by 1 minus gamma into, right, V to the power of 1 minus gamma. Okay, so there is no dV, sorry. Right? there is no dV. Where the limits goes to what? Vi to Vf. Here also Vi to Vf. So let us substitute limits in that equation. So finally what we get if we substitute limits in that equation? Substitute the limits. So what we get there after substitution? We'll get there W equal to so 1 by 1 minus gamma K by 1 minus gamma into substitute here Vf into power 1 minus gamma minus here we'll write Vi 1 minus gamma, right? So after substitution of limits. Now what we have to do here, we know that PV power gamma equal to K, right? So here this can also be written as where depending upon our requirement, I am writing this one as, see there, I am sending K inside, then what we get W equal to 1 by 1 minus gamma into K value, substitute K value there, then we'll get a Pi Vi gamma into, this is what final volume and final pressure. So this can be written as Vf to the power of 1 minus gamma minus Pi Vi to the power of gamma into, so where we have the term Vi into 1 minus gamma. Right? Instead of K, let us multiply K inside and substitute these values. Instead of K, let us substitute Pf Vf power gamma and Pi Vi to the power of gamma. Right? And multiplying this, what we get 1 by 1 minus gamma into, so we'll get there Pf Vf minus Pi Vi. So this is our required equation work done during the expansion of the gas in the adiabatic process, right? W equal to 1 by 1 minus gamma into Pf Vf minus Pi Vi. So understand, so this is a very important equation work done during the expansion of the gas in adiabatic process. So after a little bit changes, we'll write this one also. For example, when the gas is compressed during the compression, otherwise when the gas is compressed, we'll write this one as W equal to, so when the gas is compressed means the work done on the system can be taken as negative. Already I told you. Then multiply with minus, we'll get there 1 by, so here you have to write 1 minus gamma into, so we'll write Pi Vi minus Pf Vf. Okay, so this is the work done during the compression of the gas. Now, in terms of temperature also we'll write this equation. We know that PV equal to RT. Substituting that one, we'll get here W equal to 1 by 1 minus gamma into, so here we'll write a T1 minus T2 into R. So you have to write like this. See there? What I am substituting there? PV equal to RT. Using this formula, instead of PIVA, I am substituting R into T1 or TI. You have to write TI here. So instead of PFEF, I am writing RTF. So here you have to write F. Okay. Then we get W equal to R by 1 minus gamma into Ti minus Tf. So this is the work done during the compression of gas in adiabatic process, right? So this is the important equation, right? Let us end the topic. Thank you.